October 7th, 2025. The European Space Agency just dropped what could be the most important image of the decade, a faint, almost invisible smear captured near Mars. The object is officially named 3I Atlas, only the third confirmed interstellar visitor ever detected. For weeks, astronomers have waited for this moment, expecting clarity, maybe even revelation. But instead of answers, ESA's release delivered a mystery. A single flickering dot surrounded by an eerie halo of carbon dioxide, and then silence. No statements from NASA, none from China or the UAE. Tonight, as 7 spacecraft circle Mars and the world stares at one uncertain image, a single question burns through every control room. Did we just photograph a comet or something far more deliberate? 3I Atlas was never supposed to exist in this orbit. When telescopes in Hawaii first logged its path in late August, its geometry was already strange. A hyperbolic curve cutting just 5 degrees off the ecliptic plane, threading precisely between Mars in October and Jupiter by March. Statistically, that alignment should happen once in 10,000 random passes. Astronomers labeled it interstellar and moved on, expecting a cold, harmless rock. But within days, the data began to argue back. No trace of water vapor, no ice sublimation, only carbon dioxide and atomic nickel. That combination doesn't match any comet cataloged in human history. Then came the frame from Mars. On October 2nd, Perseverance's Skycam, a weather camera meant to track dust storms, caught a pale circular glow above the horizon at 9:18 a.m. local time. A dot barely brighter than background noise. Engineers nearly deleted it until Mallory Leffeland, the rover's shift lead, insisted on running one more filter pass. Her gamble paid off. The anomaly lined up perfectly with Atlas's predicted coordinates. Within hours, the raw image leaked through NASA's servers, annotated, circled in green, and the world's telescopes turned toward Mars. Yet, as days passed, no follow-up images came. NASA cited a shutdown. China and the UAE offered nothing. Only ESA broke the silence, calling the object chemically atypical. For a comet expected to behave like all others, Atlas had already broken every rule. By the first week of October, Mars had become the center of a global observation campaign. 7 active spacecraft, all with different sensors, were pointed toward one target. The Mars Reconnaissance Orbiter prepared its high-rise camera, capable of spotting a rover's tracks from orbit. ESA's ExoMars Trace Gas Orbiter activated its KSSIS imager for faint, moving sources. Mars Express readied 2 spectrometers, Omega and SpiceHam, to analyze gases. China's Tianwen-1 aimed its radar array. The UAE's Hope probe adjusted its ultraviolet monitors. Even Odyssey's thermal camera joined the lineup. It was a moment no simulation could reproduce, an entire planet becoming humanity's outpost for an interstellar flyby. Then ESA released the first processed result. October 7th. The KSSIS animation showed a dim speck drifting through blackness. Barely distinct from digital noise, for the public, it looked disappointing. For scientists, it was electrifying. Within that faint shimmer lay data that shouldn't exist. Spectral lines confirmed a coma, 95% carbon dioxide, an impossible ratio for a comet. Hydrogen-oxygen lines, the fingerprints of water, were missing. Nickel emissions spiked, but iron was absent. On Earth, nickel without iron occurs only in an industrial process called carbonyl extraction, where heated carbon monoxide strips metals with surgical precision. Across Europe, research teams at DLR and INAF cross-checked the signal. Instruments were recalibrated, stars reobserved, control comets reanalyzed. The anomaly persisted. Negative polarization readings reached -4%, twice the strongest ever recorded. In plain language, Atlas's dust scattered light backward, as though each particle were coated in dark metal. No calibration error, no software glitch could fake that pattern. It was consistent across independent telescopes. One senior analyst wrote in his internal log, "Either this is a comet made of something we don't understand, or it's reflecting design." Every attempt to fit Atlas into natural models failed. No known combination of temperature, spin rate, or outgassing could explain the nickel signature or the optical reversal. As ESA scientists argued for caution, private observatories began whispering another term: engineered reflectivity. What that means, if true, could upend everything we know about what moves between the stars. Tonight, every antenna from Canberra to Madrid is tuned toward Mars. The European Space Agency has confirmed that this will be the last clear window before 3i Atlas disappears behind the Sun for 2 full weeks. Beginning at 21 UTC, orbiters above Mars will coordinate an observation sweep. ExoMars will record in visible and infrared. Mars Reconnaissance Orbiter will try for high-resolution optical frames, and Mars Express will map the comet's spectral spread. NASA has issued no statement, but insiders at JPL confirmed that emergency protocols are active, even with much of the agency furloughed. In Pasadena's control room, a skeleton crew sits through the night, watching the telemetry stream for a signal pattern that doesn't belong to natural light. What makes this night critical isn't just visibility, it's the physics of opportunity. Once Atlas crosses its perihelion on October 29th, its distance from Mars and the Sun's glare will make optical tracking almost impossible. Any outburst, spin change, or deviation in course that happens now will determine the truth. If it brightens steadily, it's a normal comet venting gas. If its brightness fluctuates at regular intervals, that suggests controlled rotation or pulsed jets, an artificial behavior. Even a fractional change in trajectory could mean a course correction, a move that no rock could execute on its own. ESA's Operations Center in Darmstadt is running simultaneous downlinks through the Deep Space Network. Engineers describe a quiet tension, the kind felt before planetary landings. Everyone knows this data won't just decide one comet's classification, it could define the boundary between natural and technological astronomy. A mission planner from the UAE, speaking anonymously, admitted, "If it moves against prediction, we'll need to rewrite the entire category of interstellar objects." Outside the agencies, the world is waiting. Newsrooms, Reddit threads, and university observatories are live tracking every ESA ping. Tonight, for a brief window, humanity's instruments are focused together on one speck beside Mars, listening for the universe to answer back. As data trickles in, scientists around the world have outlined 3 possible scenarios for what 3i Atlas might be, each more unsettling than the last. The first, and most conservative, is that Atlas is natural but extreme. Under this model, the object is a carbon dioxide-dominated comet, stripped of lighter elements after millions of years in interstellar space. Long exposure to cosmic rays could have erased its water ice and altered its chemistry, leaving a shell that vents only heavy volatiles and metallic gases. If this is true, the nickel spikes seen by ESA are the chemical ghosts of a frozen core, unlike anything in our solar system. It would still be historic, a new class of comet, but one safely explained by nature. The second scenario is less comforting. Atlas might be fragmenting. The erratic light curve detected by ExoMars could indicate that the nucleus is breaking apart, its pieces tumbling unpredictably. When comets rupture near the Sun, they sometimes eject shards with velocities that defy gravity, producing brief flashes of light and sudden drops in brightness. If fragments of Atlas drift toward Mars's orbital path, they could become micro-impactors months from now, too small to threaten a planet, but large enough to leave a signature in the Martian atmosphere. It would mean the object's structure was fragile, hollow, or irregular, a survivor on borrowed time. Then comes the scenario scientists discuss in private, and politicians dread to name. What if Atlas is not behaving naturally because it was never a comet at all? The hyperbolic trajectory that threads so neatly between planetary orbits resembles a gravity assist maneuver. The carbon dioxide coma could be the byproduct of a controlled exhaust or chemical shielding. The nickel-only chemistry, impossible under natural formation, mirrors industrial catalysts used in high-temperature engines. Even the negative polarization might suggest a surface engineered to absorb or redirect light. No one is claiming evidence of construction, but no one can prove absence of it either. A confidential ESA report leaked late tonight used new terminology: non-gravitational motion under evaluation. In past missions, that phrase referred to active spacecraft. The scientific community, usually allergic to speculation, is now forced to weigh probabilities that once belonged to science fiction. If the natural models fail, Atlas could mark the first verified technology from another star system, an artifact adrift and ancient, caught for a moment near Mars before it vanishes again into deep space. If Atlas turns out to be more than a comet, the consequences reach far beyond chemistry. A discovery suggesting engineered origin would ignite the most profound political and philosophical crisis in modern science. Even now, disagreements over data control are widening. ESA insists on transparency, promising to release raw telemetry once its 6-month embargo expires. NASA operates under U.S. federal review, where national security clauses conceal entire datasets. China's CNSA and the UAE's space agency remain silent, citing ongoing verification. In practice, that means the most extraordinary evidence humanity has ever gathered may already be compartmentalized behind competing protocols. Astrobiologists warn that this secrecy could fracture global collaboration. Since the dawn of the space age, science has been open by necessity. Peer review and replication are its lifeblood. But if Atlas shows even a hint of artificiality, governments will treat it like classified material. Who decides what the world should know? A handful of administrators, a council of scientists, or the nations that paid for the spacecraft? For many researchers, this is the ethical frontier of discovery itself. Beyond politics lies something deeper. Atlas's carbon dioxide dominance challenges every model of comet formation. Its nickel-heavy emission suggests metallurgy on cosmic scales. Even if nature alone forged it, we will have to rethink how interstellar chemistry evolves between stars. Funding priorities could shift overnight. Missions like JUICE, Juno, and Mars. Sample return might be retasked to hunt for similar anomalies. The next generation of telescopes could be built not just to observe, but to intercept. And for ordinary people, the millions watching tonight's live streams, Atlas has already changed something fundamental. It has reminded us that the universe is not finished surprising us. Whether this visitor is dust, ice, or device, it has made humanity look outward together, if only for a moment, waiting for a signal that may never come. Behind every clean press release and carefully worded statement are people, exhausted, wide-eyed, and barely breathing between shifts. In Darmstadt, ESA's mission control glows with monitor light as engineers sit shoulder to shoulder, whispering over lines of raw code. Across the Atlantic, inside a half-lit control room at JPL, a handful of furloughed scientists have volunteered to stay, monitoring packet losses from Mars that may contain the next clue. In Beijing, an anonymous source posts a single line to an astronomy forum. Telemetry anomaly confirmed. Within minutes, the post vanishes. At observatories across Earth, the amateur astronomers, the ones who never sleep, are already part of the mission. In Tucson, a retired software engineer has built an improvised tracking system, feeding images directly into an open-source pipeline. In Spain, a high school physics teacher uses a backyard telescope to capture the faintest hint of movement between frames. Around the world, data threads merge in real time, a collective nervous system of curiosity, feeding on silence. Among them is a 26-year-old intern named Leah Verhoeven, working the night shift at ESA's Image Lab. Her job is to flag cosmic rays that distort frames before release. But tonight, she stops at one file, a pattern repeating every 42 seconds, subtle, rhythmic, consistent. She writes a note, possible mechanical interval, pending confirmation. No one will read it until morning. These unseen people, the interns, technicians, and dreamers, are the quiet pulse of exploration. They aren't chasing aliens or fame, they're chasing understanding. And as Atlas fades into the solar glare, it is their persistence, not the machines, that keeps humanity's eyes open. Long after the data is archived, their fingerprints will remain in the code, the coordinates, the hope that when the next signal appears, someone will still be awake to see it. By dawn, the faint signal from Mars will fade into solar noise. The telescopes will close their shutters. The orbiters will switch back to routine calibration, as if nothing extraordinary ever happened. Somewhere behind the blinding corona of the sun, 3i Atlas keeps moving, silent, unbothered, obeying a course that may not be random at all. For the next 2 weeks, the entire inner solar system will be blind. No camera, no radio dish can see through the storm of plasma that hides the visitor. Humanity, for once, has to wait. In that waiting lies the lesson. We've spent decades building machines to understand the universe, assuming that more data would always bring more certainty. But the image ESA released, a single trembling dot, has done something no perfect photo could. It reminded us that discovery isn't about answers. It's about the questions that refuse to die. Whether Atlas is dust and ice or artifact and alloy, it has already served its purpose. It forced the human race to look up again, together. When it reemerges in late November, ESA's JUICE probe will aim its instruments toward its path near Jupiter. Juno will follow months later. Somewhere in those future frames may lie the proof that changes everything, or nothing at all. Until then, all we have is the knowledge that something from another star has brushed our world's horizon and slipped away, leaving us with wonder, doubt, and a humbling reminder that the universe still writes stories we cannot yet read. And as the light of Mars fades into the void, one truth remains. Whatever 3i Atlas truly is, it has already done what every great mystery in science does. It made us question who we are, and what kind of intelligence we might become when we finally learn we are not alone.